For a hyperbola that is not centered at the origin, we can use h comma k as its center. This actually gives us two equations for hyperbolas. This equation has the x squared term coming first, so the parabola will open to the left and to the right. H and k will be our center, and the value of a will be how many units we move in the x direction, and the value of b will be how many units we move in the y direction. This allows us to graph our ellipse and then draw the box around it for our rectangle. Other hyperbolas, however, open up and down. These hyperbolas start with the y squared term. This term will be positive instead of being negative. But notice that h and k have been switched here. H is still with x and k is still with y, but k comes first in this equation and h comes second. So you want to keep this in mind when finding the center if a hyperbola opens up and down. The h value will be this value, and the k value will be this one. This might be confusing, but you can always remember that anything associated with the x direction will be with the variable. For example, the x-coordinate of the center will be h. That's with the x. And the way we move in the x direction, a, will be here, underneath the x squared term. Likewise, anything having to do with the y or the y direction will be next to the y variable. The y-coordinate of the center, k, is here, and the way we move vertically up and down, the value of b, is here. These equations aren't that different, and really the things with a squared and b squared work exactly the same as before. The only difference is that this hyperbola opens left and right, since the x squared comes first, and this parabola opens up and down, since the y squared term comes first and is positive. The other subtle difference is hk. Here they're in order, h and then k. Here we need to be careful and get the h next to the x, and then get the k that's with the y.